Hello, everybody, and welcome to the Kemper Creative Learning Studio. My name is Denzel, and we're going to find out what's a matter today for our show. Now, that's actually a great question that I can ask all of you. What's a matter? I tell you what, let's start off by doing this. I want you to take a look around where you're sitting or standing right now. Go ahead and look straight up above you. Great. Look down below. Look to your left. Look to your right. Look towards a parental unit that may be assigned to you while you take your trip on planet Earth and wave to your parental unit. Hello, parental unit. Great. Wonderful. Everything that you just looked at is matter. Matter is anything that has mass and volume. So mass is something that has weight, okay? Volume is something that takes up space. I have mass, as you can definitely see, and I take up space, as you can definitely see. Here's another thing I'd like for you to do. Around you is probably something, okay? Some item floating around. Why don't you go ahead and grab that? I happen to have this item right here, my glass bowl. Just hold on to it, and I want you to feel it out, okay? If it weighs anything, go ahead and go up and down with it. Great. Weight, that's mass. And if it takes up any space. Now, my glass bowl does take up space, even though it may be hard to see. It takes up this amount of space that's around me. Okay, great. So now that you've discovered an item that is around you, you have mass and you have volume. Let's do some fun stuff with it, because this item that you probably held is a solid. But what is a solid? Well, it turns out matter can be existing in different states. Okay, one of those states is the solid. Solids are fixed in their shape, which means they don't typically change. Even though I'm pushing on it right now and pressing down on it, it's staying the same shape, okay? It also has a fixed volume, which means it occupies the space that it's in, and it doesn't really change wherever it's going to be. So even if I move this shape over here, guess what? It's now taking up the same space. It's just from here to there. But we can do things, we can find out about other types of states. So while you think about two other states of matter in your head, I'm going to go ahead and find some supplies for me. Great, supplies, look at that. And we're going to do some exploration with the stuff that I have over here. Okay? Now that you may have thought of those two other states of matter, but let's take a quick journey on understanding how they can exist. So let's all close our eyes for a moment, for a longish moment. Just close your eyes, and I want you to think of balloons. Now, I had them earlier, so hopefully you have a great picture of balloons. Think of a cluster of balloons, like, say, 2 balloons, okay? And now add 3 balloons. Now have a 4th balloon. And now have a 5th balloon added to your cluster of balloons. Go ahead and open your eyes. Look at that. Magically, all 5 of those balloons you were thinking of are now inside the studio. Of course, yes, they were there the whole time. So, the cool thing is, our balloons are going to help us understand something called particles. Now, particles are normally really tiny, but I blew them up so that you could see them a little easier. So particles, when they're arranged closely together like this, and they all move almost as one, is going to represent a solid. Now, if you have a bunch of balloons at home, you can do the same thing. Just tie them on some strings, get yourself a loop, and have some fun with it. So this represents a solid. Particles that move together, they have about the same amount of energy inside of them, are solids. It's the same thing that's happening inside of here. If I were to zoom in really close and use my awesome vision, I could actually see a bunch of tiny particles that are being added up to make our glass bowl. So that's a solid, but what about a liquid? Okay, liquids have a little bit more energy to them, okay, and they are allowed to move around a little bit more. They still stay close together, but what they end up doing is having that more energy, and they move around a bit more. Now, what I can do with this is actually show you something really cool about liquids. So let's place our balloons back up in there, and let's grab some supplies. All right, let's move my glass bowl over there. We'll come back to that in just a moment. So one of the things about liquids is that they change their shape, but they maintain the same volume. So they will occupy the same amount of space, but they will change to whatever shape they're put into. So right here, we have about 300 milliliters of water, okay? So I'm going to pour this water into these various sized and shaped containers, and we're going to see what happens to the shape of the water. Ooh. If only you could hear the sounds. That was a cool sound. All right? So we can see that the water has changed shape, but it's still taking up the same amount of space. You might not notice it at first, but wait until we get towards the end, and hopefully we'll still have 300 milliliters of water. Let's pour again. Oh, I spilled. Alrighty. There we are. It looks like it changed shape once more. And finally, let's go back to the first one we started off with. Hopefully, even with a loss, we still have about the same amount left into our container. We're still at about 300 milliliters. So this tells me that we had the same amount, the same volume, the same space amount of water, of liquid, and as we moved it to glass, it was able to change shape. So water, liquid, has a little bit more energy than gas. It can change its shape, but it doesn't change its volume. Let's move that out of the way and go back to our full balloons over there. We'll dry this off. All right, please do that experiment at home. See how many different types of vessels that you can put water into. First try. So, back to our balloons. We've seen a solid. You can pretend to be a solid. All you have to do is sit still or stand still. Great. Add some more energy to you. You become a liquid. You move like a liquid. You move like a liquid. Okay. We have a liquid with our balloons. Ooh. Now it's time to be a gas. Gases have a lot of energy inside of them. Gases are given a lot of space, and they move around like this. Now it's your turn to be a gas. Gases are fun. I like gases. Let's put you back, balloons. Because we can do something fun with gases to prove that they are also matter. So I'm going to go over here and grab a larger container. This is something I want you to do at home too. You probably have some baking soda and vinegar, and all you need is a cool measuring apparatus. So my cool measuring apparatus is a ruler and some plastic bags. Alrighty. Whoa. Oh, you know what? Hang on, let me dump some of that air out. Great, and now we have ourselves a balance. You have to tweak with it once you get yours at home too. There we are, perfect. Now, while that's figuring itself out, let's go ahead and mix up a batch of carbon dioxide. Baking soda, I didn't measure, it's okay. We don't need to measure for this one. And vinegar. The sweet smell of vinegar. Those bubbles tell me that a nice chemical reaction has occurred. That's a whole nother show. You should check that show out too. But the point of doing that was we needed to get some carbon dioxide. Now, I could have made carbon dioxide. You do it when you breathe out. But it would have taken forever. I wanted a whole bunch as fast as I could make it. Because I'm going to pour air into our bag. And I'm going to prove to you that air has mass. So that means it has some form of weight. So here we are. Let's pour the gas into the bag. It's pretty cool, isn't it? Let's see if I can pour it on the other side and make it a little bit more even. I know it looks like I'm pouring absolutely nothing in there, but I am pouring carbon dioxide into that bag right now. Carbon dioxide is denser. It's heavier than the air around it. So I got them almost even all over again. Let's see if I have just a little bit more carbon dioxide left. I am all out. If I go any further, I'll start pouring liquid, and I don't want to do that. So by allowing ourselves to see that it became unbalanced, it proves to me that there is air that's heavier than that there's air that's heavy, and because air has weight to it, it was able to change our scale. Let me put this away so I don't trip over it and move it out of the way. Please do this one at home. It's super fun. You can use a yardstick. You can use brown paper bags. You can even inflate balloons. Inflate one balloon and keep the other balloon uninflated, and then you can actually do the same thing. Super fun. So now that we've seen the different states, let's go ahead and add them to my bowl. We have ourselves a solid. This one is a liquid. Remember, liquids change their shape, but they do not change their volume. Gases, they change their shape and they change their volume. So let's go ahead and fill this up with the gas. Done. Okay, fine. Let's do another solid. Why don't we? Because that's not good enough for me. I have another solid inside of here. It is really, really hardened water. You can call it ice. Water is very fun because it can exist in at least 3 different states. It can exist in a solid form, a liquid form, and a gaseous form. So, let's put that in there. And now we have ourselves a matter soup. I like matter soup. It's delicious and refreshing. You should have some every day. So now that we have that, we have solids, liquids, and gases in our matter soup, and it looks very, very delicious. We've seen different energy states, and we understand that each one of these things have mass, that they have weight, and they have volume, which means that they take up space. So now it's time for us to do some other experiments with them. All right, one of those things that we're going to do is actually change from one state to the next. And for that, I'm going to need some hot, some heat, some warm energy. So let's pull out various cooking supplies. I'm going to just turn this on right now to high, turn this one on to high, and we have to be careful around these so we don't get ourselves a little warm. Now, I don't know about you, but one of the favorite things I like to make in the kitchen is something called fried ice, okay? If you've never had fried ice before, you should try it. It's delicious. You need a pot. You need some ice or a pan. There you are. That's it. That's all you need. Just some ice and a pan and some heat. While that's cooking, we're going to go ahead and do something else as well. This is an experiment I definitely want you to do at home. So right now we're adding energy to that fried ice right there, and we're going to see what that turns into. We're also going to add energy to some water. Now, I've already prepped one so we can get this one started, but I'm going to show you how to do this experiment where you're sitting right now. You'll need a can. Aluminum can is the best. And make sure it doesn't have any type of like plastic graphic on it. You're going to just fill the can up a little bit with some water. I'm using a pipette, but you can just pour in a tablespoon or 2. I'm going to use a piece of tape over the mouth. You do not have to use this, but I prefer to use this. It helps me get a cool jet of steam that I want to see to allow me to know that it's done. So the objective of what we're doing here is we're actually exciting or adding energy to the liquid. We want to move from one state to another. In this case over here, our fried ice should probably be just about done. And you can see that that solid that we started off with is now no longer a solid. Instead, it is a liquid. Here we are. Oh, fried ice is delicious. Yeah, They were dancing. So, oh, perfect. Look at that. We've got ourselves some steam. That's exactly what I was looking for. That steam is telling me that we've taken the water, which was a liquid, we've added enough energy to it to turn it into a gas in the form of water vapor. So if I pull off our cool tape here, 3, 2, 1, into cold, we should get ourselves a fun reaction that has occurred. This is a pressure difference. Let's try it again, actually, with the Mountain Dew one over here. Let's see if we can put that one back on there. You can do this with any aluminum can. You can do this experiment by adding energy to the water inside. How does it work? I can feel you asking that question. How does it work? The liquid, remember earlier we had those balloons. They were super excited. Okay? The liquid, as it gets excited, it starts to go and fills up the space inside of the can. As it fills up the space inside of the can, it has a lot of energy, really, really high energy. When we put it in the ice water, we take that high energy and we remove as much energy as we can, as fast as we can. And as a result, we get ourselves a change in pressure. The balloons are no longer bouncing around. Instead, they get pulled together. This one's super fun. Do this every time you do recycling. So this was our example of adding energy, and removing energy. There's another way I can remove some energy, though. Back in my cooler, I have a way to do this. So let's move our pans out of the way. Make sure we're safe. And, of course, we'll turn you off. All right. Goodbye. I have a cup in here that I'm going to borrow you. I've been keeping this cup nice and chilled because we're going to pour some water into it. And I want you all at home to go ahead and take a deep breath in. And I want you to blow on this cup. You're going to use your awesome, super cool breath from your house. Here we are. 3, 2, 1, blow. Perfect. That was great. Look at this. Ha-ha. You've chilled it. You've taken the water, you've used your super cold breath, and you've cooled down the water and turned it into a solid. Or okay, some of you are like, no, you really did that. I didn't use anything that would make it cool down faster or turn into a solid. Nothing at all. Nothing to see here. Let's move that out of the way. Nothing to see. Look, cold things, they make things turn into solids. Remember that. You can do it at home. It's called PolySnow or instant snow. Have some fun with that too. So, here we are. We've gotten ourselves energy in different states. We've got ourselves matter in different states. We got to different states by adding or removing energy to it. But there's some other fun stuff that we can do with it. Because not all matter that you run into is a little bit different. So the common ones are going to be your solids, your liquids, and your gases. Okay? Those are the ones you run into every single day. Now, what you're going to end up doing for this one, this is another state of matter. It's called a plasma. I like plasmas. Plasmas are really, really excited gases. Okay? They're so excited that they actually begin to kind of break apart. Now, some of you may have one of these at home. It's called a plasma ball, and it allows us to kind of see plasma at work. Now, the plasma inside of here is electricity is going through and exciting the gas that's inside of the ball. And as a result, we get ourselves what's called an ionization happening. And that is going to be super, super charged particles. It's a plasma. You see plasma every time that you wake up and the sun is outside. You're going to see plasma occur because sun is a plasma. You also see it in the trails of lightning. When lightning strikes, boom, you get yourself a plasma trail. Now, here's a great example of how this plasma is working. So earlier we discussed those particles. I'm going to turn this. Actually, you know what? I can touch this one. Okay, cool. Normally you can't touch plasma, and I don't recommend you do so. But that one you can. So, earlier we discussed those particles. Well, those particles have things inside of them. Those particles are representative of atoms. Inside the atom is a nucleus. That's that pink thing. And outside are electrons, and they're doing this. They're bouncing around. They're having a lot of fun. Plasmas do this to an atom. Now is a great time for you to go ahead and place your ears on. For those of you at home, you can temporarily turn down your volume, or you can just cover your ears. Adding energy. 3, 2, 1. You can take your ears off or turn your volumes back up. Plasma is so excited, it actually takes the atom and goes boom and blows the atom apart. You have electrons floating around in space all around it, and you have your nucleus in the center hanging out, and they're separate from each other. That is an excited state of matter. So that's a fourth state of matter. There actually is other states of matter, but unfortunately I can't reproduce them in the studio. However, I can show you a different way that you can go from one state to another. It's called sublimation, and I actually really like this one as well. Let me go back over here. Get out of the way, electrons. Inside, I have dry ice. Now, dry ice is cold stuff. It's around 109 degrees below zero. Whoa! Let's bring back our matter soup. Now, dry ice is a solid form of the stuff you breathe out all the time. Okay? It's CO2, carbon dioxide. So when you go and breathe out, if you get that really, really cold, you remove energy from it, it condenses to a solid. If you're not sure what condensation is, you're actually seeing it right here on the outside of the bowl. This is condensation. The gas around the bowl got super cold to the point where it actually condensed. It made water on the outside of my glass bowl. You can do that at home, of course. Anytime you have like nice cold lemonade or tea, you can do this on a nice warm day. Condensation is occurring. Now, if I take our solid form of carbon dioxide, drop it in our water, we get ourselves this really awesome situation happening. You see, the solid carbon dioxide is going from a solid state and jumping straight into a gas state. It's called sublimation. It never goes into a liquid state. Normally you go solids, liquids, gases, but this one's like, what's a liquid? And goes boop right into a gas. It's amazing. You can see that happening from the bubbles that are popping up from the solid. Come here. Now, even if we didn't show bubbles, you can actually see this occurring right here in my hand. We have ourselves the solid, and all the stuff that's coming off of it is really, really, really chilled gas. The CO2 rock here, this dry ice, is actually going into a gaseous state. It's warm enough in the studio that it's going straight into gas, and there's no liquid on my hand at all. It's really, really cool stuff. I like dry ice. Now, we've seen ourselves solids, liquids, and gases. We move from one state to another by adding energy to a solid to get to liquid, adding energy to liquid to get to a gas, and we even added energy to a gas to get to a plasma. If you remove energy, you go back down the chain. Plasma to gas, gas to liquid, liquid to solid. Remember, solids stay straight, liquids flow, gases go, Aah! So there's one more thing I want to do with a gas, and that's to go, Aah! With some fun right over here. My last part of the show, we'll be using some fire juice. Hey, I don't need these gloves anymore. Bubble away, dry ice. Bubble away. We're going to add a liquid into each of our canisters. The liquid will go through a process called evaporation. Evaporation means the liquid goes to a gas. Okay, it's warm enough right here that it's adding enough energy to the liquid and becomes a gas. We're gonna try for 4 out of 4, but I bet you we may get 3. So let's cross our fingers and see if we can get 4. To make this work, we need more energy because it's not enough to just be a gas. We want that gas to rapidly expand and cause a teeny tiny explosion inside of our canisters. So now's a good time for you to go ahead and place your ears back on. And let's bring out, my friend, the Tesla coil. Here we are. 3, 2, 1. Well, we have just answered the question, what's a matter? Remember, it's anything that has mass and volume. That means if it takes up space or weighs something, it's a matter. You matter and I matter. Do some of these experiments at home and let us know how they all went. Thank you all so much for tuning in. My name is Denzel. Have fun. Stay safe. Thank you so much.